Welcome back to my channel. I hope everyone is doing great. Let's solve Leetcode problem 84, largest rectangle in histogram. Given an array of integer heights represents the histogram's bar height where the width of each bar is 1, return the area of the largest rectangle in the histogram. Okay, so as you can see, this is an histogram with different bars and different heights, and we have to get the maximum rectangle in this histogram. Okay, so if you see, this itself is a rectangle, this itself is a rectangle, and you can see this is also a rectangle which is of 5, height of 5, and breadth of 2, which is also 10. And if you see, this itself is a rectangle which is of area 6, and you can see this 2 can be extended till here and can also be extended towards its right, and this has an area of 2 times 4, which is 8. Okay, and this is also area of 10, and so on and so forth. Okay, so how can we solve this? Okay, if you closely observe, the histograms can be divided into two patterns. Okay, either small followed by height, the larger bar, or larger bar followed by the small bar. Okay, so first can be the bar with greater height and followed by the smaller height one, and or smaller one followed by the greater one. Okay, in this case, okay, let's say we have encountered a bar which is of height 2 and followed by another bar of height 1. Okay, so in this case, this bar cannot be extended towards its right. Okay, but this bar can be extended towards its left. Okay, so whenever we encounter a bar which is of lesser height, okay, so we have to basically remove this bar and calculate its area, because this can no longer be extended towards its right. Okay, so we'll just remove it and calculate the area as 2, but this one can be extended towards its right. Okay, so let's also consider this. Okay, 1 followed by 2. Okay, if you see 1 followed by 2, that means 1 can be extended towards its right. Okay, so this is still be part of our uh, considering space. Okay, but if you see 2 can also be extended. We don't know what will come towards its right. Okay, so depending whether it's this, whether it's a larger bar or smaller bar, will take an action. Okay, let's take this. Okay, so 2 followed by 1, we have already removed 2 from our considering space, and 1 will be extended towards its right, towards its left. That is what I mentioned. So what we'll say, we'll just say keep, instead of seeing 2, we'll say 1 has started, we'll say 1 has started from 0th index itself. Okay, and 3, we have encountered 3 is larger than 1, we'll keep it as it is. Okay, we'll still consider it, we'll consider it for to extending it towards its right. Okay, 1 2 3. Okay, let's take this 1 followed by 2. Let's say if 3 comes here, that means 2 can be extended towards its right and 1 can also be extended towards right. Okay, so both can be extended. Okay, so let's say after 3 we have encountered 1. Okay, now 3 cannot be extended further. Okay, that means we have to remove 3. So we'll say the area of this would be the index of this minus the index of this, which is 4 minus 3, which is of 1 times 3. So the area of this rectangle is 3. Now this has been removed. Now we have 1 and 3, but the index of this is still 2. Okay, let's keep it in its exact position itself, just to uh, understand what is its position. Okay, now 2 cannot be extended further. That means I should also calculate the area of 2. If you see 2 can, if 3 is ideally here, that means I can consider an area of 2. So this index minus this index times the height of this, which is 2 times 2, which is 4. So the maximum area so far is 4. Now I will also remove this. Okay, now I have 1 and 1 is equal, I can still extend it, so the area will be 1 times the length, which is 4. So the maximum area so far is 4. Okay, so let's look at this example. Now let's assume that we only have 3 elements. Okay, let's say this is the histogram which we have been given, it contains only 3 bars. Let's try to calculate its area now. Okay, so as, so if you observe keenly that I am actually popping an elements from my search space, so on and so forth. That means we have to use stack. Okay, so let's say initially our stack is empty. Now I have encountered 2. Since our stack is empty, I will keep 2 into my stack. Okay, okay, now I kept 2 into my stack. Now I encountered 1. Okay, is 1 greater than the top of the stack? No, it's not, right? That means I have to eliminate, I have to remove this element from the stack and I have to calculate its area. So the area would be 2 times the current index 1 minus the index at which the pop element resides. So this is pop element resides at index 0. So 1 minus 0 would be 1 times the area of this bar, which is 2. So the area would be, so the area so far would be 2. Okay. Now I have encountered 1 as a, since we have encountered 1, okay, which is lesser than this side, but this 1 can be extended towards its right. So what we'll do, we'll remove an element from the stack. We remove 2 from the stack and we'll say, but whenever we are inserting 2 into the stack, we'll say 2's position is 2. This 1 is actually starting not at 1 first index. We'll say that it has started at 0th index itself. So we'll keep 1 into back into our stack and say it has started at index 0, not at index 1, because this 1 can be extended till the way all the way up to index 0. Okay, let's also keep the indexes over here so that it will be clear for you. Yeah, sorry. Yeah, so I've processed 1. Now I've encountered a bar 3. Now since this bar is higher than the previous bar, that means I can extend my 1 towards its right. Now I will keep 3 into my stack and also I will say it, I will also store its position, which is 2. Okay, now I have reached all the way till the end. That means there are no more elements to process. Now I should also consider area of these 2 bars as well. So I will just pop this element and say this can be extended all the way up to end, but the end is itself is 2. So 3 minus the length minus the index at which it is currently residing times the height, which is 3. So I will just update my answer to 3. Okay, and I will remove 3 from my stack. Okay, this has been removed. Now I should also calculate the area of 1. So 1 can extend all the way up to the end, right? And its relative start is 0. So end of the uh, height, end of the array minus the relative position times its height, which is 3 again, which is same as the so far maximum. So the answer would be 3. Okay, so I hope you got the idea. Okay, so what we'll do, we'll just process the heights from the start to the end, and whenever we encounter a height which is lesser than the top stack's top element, we will basically, as long as we, as long as the top element is lesser than the current height, we'll just remove all the elements from the stack and process their areas, and in the end we'll keep the current height into the stack with its relative position. Okay, what will be its relatively start position. Okay, and then we'll continue processing it. Okay, so let's show you the code. Okay, as I mentioned, I will be requiring both height and the position of the bar. So I have created a class called pair which contains two fields. One is index and one is height. Okay, so index is basically at what index the current bar resides, and height is basically the height of the bar. Okay, so I also mentioned we will be requiring a stack to process the elements, and I have just defined n as the length of the heights, and I initially have defined answer equal to the min value. Okay, you can also instantiate it to 0 because all the heights are positive, as you can see. So the minimum, the least possible answer can be 0. Okay, you can do that as well. Okay, now I will be processing my bars from start to end. Okay, at in the initial position, okay, at any given point of time, I will just check, is my stack non-empty and the top element has height which is lesser than the current, has height greater than the current height. Okay, if stack contains an element which has height greater than the current element, that means those elements needs to be removed, and i have to I have to process those areas. Okay, so as long as as long as stack contains bars whose height is higher than the current bar, I have to basically pop those elements and calculate the area for those bars. Okay, so I just popped it. So every bar I popped it, and the answer would be the height times the length, which is the current index minus the index of the current bar. Okay, and the effective start would be, as I mentioned, when I pop this element, that means one can effectively start at this position, the position at which we, the position of the bar which we have popped it. Okay, since we have popped two from the stack, that means one can effectively start from the zeroth index. Okay, that is what I'm doing. I just defined a variable called start, which will tell me the current height, current bars effective start. Okay, effective start or relative start. Okay, so I'm just updating my start with the index of the popped uh, bar. Okay, and then once this loop execution is done, that means I have encountered a bar, the stack contains a bar which is lesser than the current bar. Okay, that means I can no longer extend it towards its left. Okay, so I will just push my pair into the stack. Okay, so this is what we will be stopping our loop at this position. Okay, we have encountered a bar. Okay, the stack top is 1, and then we are crossing at this position. That means this can no longer be extended towards its left. Okay, so this is when we will be stopping, and then we'll be pushing this element back into the stack, saying that all the elements in the stack can be extended towards its right, not towards its left. Okay, so now once we have processed all the elements, all the bars, that means our stack can still be non-empty. Okay, if our stack is non-empty, that means I should still consider the area for the elements which are present in the stack. Okay, I will be simply popping the elements from the stack, and then I will be calculating its area. Okay, I will be popping this element and calculating its area. I will be popping this element and calculate its area. Okay, so that is what I'm doing here. While stack is not empty, I'm just popping the element from the stack, and then I'm calculating its area. Area would be height times n minus the popped dot index. Okay, in the end my answer would be containing the maximum area of the rectangle for the given histogram. Let's try to run this solution. As you can see, all the base test cases were um, accepted, and let's also try to submit this. As you can see, all the test cases were also passed. Before jumping dive into the time complexity and space complexity analysis, I highly recommend you to subscribe to my coding channel, as I will be posting daily Leetcode videos. Okay, so let's try to analyze the time complexity and the space complexity. If you see, we are using a stack. Okay, and the stack can go all the way up to the length of the heights. Okay, let's say if all the heights are in the increasing order, that means we'll be pushing all the elements into the stack. That means the stack can go all the way up to the n. Okay, so the space complexity in the worst case can go all the way up to order of n, where n is the length of the heights. And the time complexity, if you see the time complexity for every given bar, okay, I will just either I will be pushing into the stack, and I will be removing from the stack. Okay, these are the only two operations. At max, each bar will be going into the stack and coming out of the stack. Okay, so the time complexity would be order of n here, because pushing and popping will be constant time, and we are doing this process for n times in the worst case. So this would be order of n. So the time complexity will also be order of n, and the space complexity will also be the order of n. Yeah, that's all about this problem. Do subscribe to my coding channel for more such videos. Let's grow together on daily basis by upscaling ourselves. Thank you.